Hey everybody, today we're going to learn about imaginary numbers. Now that name is a little misleading because imaginary makes it seem like these don't exist, but imaginary numbers do exist. Uh, this is getting into some of the higher level mathematics. In fact, some of the math that governs your cell phone, right? So don't think that this stuff is just completely made up, right? A lot of people hear imaginary, like, oh, well, it's imaginary. Why do we need to learn it, right? It's not even real. Well, no, I mean, it is real in a sense, right? Regardless, the imaginary number I. So the letter I is what we use to represent the imaginary number. And it's very simple, actually. The imaginary number is just the square root of -1, right? So the square root of -1 is I. Now let's just think about that for a second. The square root of 9 equals 3, right? Why does the square root of 9 equal 3? Because 3 times 3, or 3 squared, equals 9, right? Well, if the square root of -1 equals I, that would mean that I squared equals -1. Just like 3 squared equals 9, I squared equals -1. This right here is something that's going to come into play a little bit later. Now, the reason why this is imaginary, right? Think about square root numbers. When you try to square root a number like -9, until now, we couldn't do this, right? Because remember, when you talk about square roots, 3 times 3 equals 9, right? -3 times -3 equals +9. So it's not like you can just say that the square root of -9 equals -3, because -3 times -3 would give you +9. It wouldn't give you a negative number. There's no way to multiply 2 copies of the same thing and get a negative answer, unless you have the imaginary number. When you bring the imaginary number into play, this stuff becomes possible. So let me show you kind of how this would work, right? It's actually very, very simple. So when you're simplifying square roots, right? This is going back to Algebra 1. Something that you can do, let me just show you what you can do, right? If I have the square root of 10, if I wanted to, I could rewrite it as the square root of 2 times the square root of 5. Why am I allowed to do that? Because 2 times 5 equals 10, right? So the square root of 2 times the square root of 5 is the same as the square root of 10. Just like you would a normal factor tree, except the numbers have square roots on top. Well, with the square root of -9, what I can do is I can split that up as the square root of 9 times the square root of -1. Because 9 times -1 is -9. Well, I can do the square root of 9, right? The square root of 9 is 3. And the square root of negative 1 is I. So what that means is the square root of negative 9 equals 3I. 3 times I. And it's basically it, right? This is how you use the imaginary number I to simplify a square root. But 9 was a perfect square. Not all numbers are perfect squares, right? Sometimes we need to take it a little bit further. So with the square root of negative 32, the first thing I will do is split it up as the square root of 32 times the square root of negative 1. I'm just separating the negative, right? So 32 times negative 1. But this square root 32 is not a perfect square, right? What are our perfect square numbers? 1, 4, 9, 16, 25, 36, 64. Oh, I skipped one. 36, 49, 64, 81, 100, right? 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, right? Perfect square numbers. Well, it just so happens that 32 can be broken up as the square root of 16 times the square root of 2. Because 16 times 2 is 32, right? Well, if I take my 3 pieces, because basically doesn't this mean that I could take the square root of negative 32 and rewrite it as the square root of 16 times the square root of 2 times the square root of negative 1. You see that? See how I'm just taking, I broke it up first as 32 and negative 1, and then the 32 breaks up as a 16 times 2. Why did I do 16 times 2? Because 16 is a perfect square number. So, the square root of 16 is 4. I can't do the square root of 2, and the square root of negative 1 is the imaginary number, I. All I have to do is combine this, and what I'll do is I'll take the 4 and the I and put it together. So it's 4I square root 2. There's your answer. So if you're simplifying a square root that's not a perfect square number, you have to break it up using a perfect square. That way you can take the square root of that number. If the number does not have any square roots, then you just leave it under the square root. So anytime you're taking a square root with a negative number, you're going to have an I in your answer. The imaginary number, I. So this is just simplifying square roots. We're doing a lot more with this, though. So let's look at this concept here. concept of complex numbers. So a complex number, which looks like this, a plus bi, basically is a number that has a real part and an imaginary part. The real part is a, and the imaginary part is the bi. So a plus bi. That's what we call a complex number. And you can do the general operations with complex numbers. You can add them, you can subtract them, you can multiply them. You can also divide them, which we'll go over that in the next video. There's going to be 2 videos for this lesson, just to kind of break them up a little bit. So anyway, let's go through adding, subtracting, and multiplying first because they're a lot easier than dividing. So, if I wanted to add these 2 complex numbers together, you have 2 plus 3i, that's one complex number, and negative 5 minus 8i, there's another complex number. Adding complex numbers together is basically combining like terms. What I'm going to do is I will combine the real parts and I will combine the imaginary parts. This is an addition sign. So 2 plus negative 5 is negative 3. 3i plus negative 8i, so 3 plus negative 8 makes it negative 5i. And that's it. That's the answer for the first one. You're literally just combining like terms when you add imaginary numbers or add complex numbers. The next one, subtraction. Now, when you are subtracting complex numbers, it's very similar to adding them, except you have one extra step. There's a subtraction sign here, right? Whenever you're subtracting complex numbers or subtracting any polynomials, right? Basically, if there's a minus sign in front of parentheses, you need to distribute that minus sign. So if I distribute the minus sign, minus negative 6. Well, minus a negative actually makes it positive 6. This is a positive 3i. Minus a positive 3i is minus 3i. Remember, you basically just change the sign of all the stuff after the minus sign. You have to do that. If you don't do that, I can guarantee you you'll get it wrong. Minus a negative positive 6. Minus 3 minus 3. Now, this 1 minus I can just bring that down. Now that's a positive 6, right? I should put plus there. Now I can combine like terms. The 1 will combine with the 6, so that's 1 plus 6. You get 7. That is a negative 1i. So negative 1i, negative 3i. Negative 1, negative 3 combines to negative 4i. So you get 7 minus 4i. Very, very simple. You're literally just combining like terms. So when you're adding, you straight up combine. When you're subtracting, you first distribute the negative, then you combine. Distribute the negative first, then combine. Maybe you even write that down somewhere. Distribute negative first, then combine. Over here, you just combine. Now, multiplying complex numbers. This actually should look very familiar to you. So you have 2 plus 3i times 7 minus 4i. To me, that looks like a FOIL method problem. So this particular problem is a FOIL method problem. Now, you all know me. I don't really like calling it the FOIL method, or at least I don't like using it as the FOIL method. I call it the FOIL method because that's what you're used to. But really what you're doing is distributing, right? The first thing you do is distribute this 2. So if I distribute the 2, 2 times 7, 14. 2 times negative 4i is negative 8i. So that's distributing the 2. Then distribute the 3i, right? 3i times 7 is 21i, right? 3 times 7 is 21. Now, 3i times negative 4i. So 3 times negative 4 is negative 12, but it's I times I. 3i times 4i, that's going to be 12i squared. You got to be very careful about that. If you're multiplying two I numbers together, you get I squared. Just like 3x times 4x would be 12x squared, right? When you're like performing operations, you basically are going to treat I like you treat any other variable, right? It's all the same rules for combining like terms. It's all the same rules when you multiply. Now, whenever you do something like this, you have like terms, right? You have a negative 8i and a positive 21i. So I will combine those. So I get 14 plus 13i. That's negative 8 plus 21 minus 12i squared. And we're not quite done. If you recall, we said before that I squared was equal to negative 1, right? I squared equals negative 1. Well, if you look, here's an I squared. You will never, ever, ever leave an I squared in your answer. Because I squared, like I just said, is the same as negative 1. So what I can do is I can replace I squared with a negative 1. You see that? I squared becomes negative 1. So what I can do, 14 plus 13i, this is a negative 12 times a negative 1. That makes it positive 12. So, now I can combine, right? I can combine 14 and 12 because those are just normal numbers now. 14 plus 12 is 26 plus 13i. So, you look at what happened here, right? We go through the FOIL method, or really we just distribute, right? Distribute like you would any normal problem like this, right? You get 4 terms, combine like terms, take your I squared, change it to a -1. After you do that, combine again, you get 26 plus 13i. I'm going to put a little reminder up here to distribute and combine. Right here, I'm going to put another reminder that I squared equals -1. So you distribute and combine, then you remember that I squared equals -1. And then combine again. Very, very basic. So, this is adding, subtracting, and multiplying complex numbers. The next video, we will go over dividing complex numbers. This is all part of the same lesson that we're doing this week. Number of the day for this lesson is 23. 23 is the number of the day. Got it? Cool. See you next video.